Hi everybody, and welcome back to the channel. This is Ahili Bhattacharya, your statistics buddy, and today we are going to start something a very interesting distribution upon the continuous distribution. Okay, so as you can see in the screen, that we are going to study exponential distribution. Now, before you panic, I'm going to tell you that this is not that complicated as you think. By the end of this video, you're going to understand exactly what it is, where it comes from, and how to find its CDF, its PDF, all the derivations, and the mean and variance from the MGF. Because to find the mean and variance from the MGF, it is very easy, right? Okay, and we will go step by step, nice and slow. So grab your notebook and let's get started with our today's class. Now, see. Okay, now while studying these notes, you can directly click on the subscribe to this button. Then you will be redirected to my page and you can subscribe. All right. Okay, so from here, let us start with what is the definition and the PDF. Okay, now, basically, what is the meaning of exponential distribution? So, this is a model, okay? Now, let me start with a random variable. See, a random variable x is said to follow exponential distribution with parameter theta. Now, you have to remember this, that in this distribution, what is the parameter? It is theta, right? Okay, and which is greater than 0. That is the condition of the theta here, of its probability density function. Here, because we are studying continuous distributions, so here we won't be using PMF. It is that PMF was for discrete distribution, right? And for continuous distribution, we only have PDF, that is probability density function. Now, here, what is the PDF? PDF is f of x, which is comma theta is there. Now, what is this theta? Theta, as I said, is a parameter, right? And what is the PDF? It is theta into e to the power minus theta x for x greater than 0 and 0 for otherwise, right? And how do we write this? We write this as x is follows exponential theta. Okay, that is the notation of exponential distribution. And here, what is theta? Theta is the rate parameter. Like, what does it mean by the rate parameter? It basically means that it controls the how fast the distribution happens, right? How fast the distribution basically decays. We are talking about exponential distribution, right? So that is what this means. Now, you might have a question like, why does this distribution even exist? Like, what does it model? What is the use of this distribution? Now, I'm going to tell you that this is a very brilliant question. Before learning anything new, you must question, like, why do we need it, right? So, I'm going to answer this to you. See, the exponential distribution models the waiting time between events. Like, for example, if I give you a few of the examples, then you might have a relatable feeling to one of the distribution you have already studied from me. Okay, so let me give you the examples. Suppose the examples are: how long until the next customer arrives into a shop? Okay, or the next example can be: how long until a radioactive atom decays? And the next example can be: how long until your phone battery dies? Now, do you find a little bit of similarity with the questions and Poisson distributions examples? Like, it does have a link, right? Now, I'm going to tell you that you will find this very relatable, because Poisson distribution and exponential distribution are basically the same thing, but Poisson distribution is for the discrete distribution, and for continuous distribution we study the exponential distribution. All right, so anything, like, basically this models anything when you are asking how long do I have to wait. Okay, that is this exponential distribution answers you. Now let me come to, yes, did you see the graph? Now, what does this graph tell you? This is the PDF graph, right? So, in this graph, you can see that on the x axis we have the time, and on the y axis we have the probability density function, which is the f of x. Now, the curve starts at high at x equals to 0, meaning this is a short waiting times are very likely, and then it decays smoothly and exponentially towards 0 as x increases. The larger theta is, the faster it decays, okay? And the smaller theta is, the flatter and more spread out the curve is, okay? So I was supposed to give an interactive slide for this graph, where I could have shown you that if theta is more and theta is less, what changes happen in the graph. If I can, I will put this in the slide back in the that interactive graph portion later on. But for now, just study like this and just imagine what I'm trying to say. Okay, so basically, what does this mean? That high theta means events happen frequently and short waits. Okay, and low theta means what? That events are rare and we have to wait for a long time. So this is basically what this graph can tell us and what the theta can tell us. Okay, now coming to the next portion. Okay, so here we have the cumulative distributive function. So now you can see, just see the animation. Now here, what is this? Is the PDF we just learned, right? This is the PDF graph, but this is the CDF graph. Now from this graph only you can understand what does there is a contrast between PDF and CDF. Now see, for CDF, we denote it by capital of Fx, right? And do you remember that CDF questions us that what is the probability of capital X which is less than or equals to small x, right? So mathematically, we have to derive from minus infinity to x of ft dt. Integral of it, right? So we will split onto two cases, right? What is the first case I can see? Just a moment that I scroll up to the first case. Okay, where is the first case? Okay, as I can see that here I have given the derivation of the second case, because that is important. Okay, I will show you in my journal that what is the how do we write the first case and the second case. Okay, so basically the first case is that x is less than 0, and for x is less than 0, that is very intuitively we can say that it will be 0, right? That is why I have not given here in the case 1. Why am I saying that it is 0? Since f of x is equals to 0 for all x is less than 0, the integral from minus infinity to x of f will simply be 0 only, right? So f of x is equals to 0 for x is less than 0. Like this is easy, like nothing happened yet, right? So probability is 0. Then from the next case, the case number 2 is that x is greater than 0. Now here it gets interesting. Here we will split the integral from minus infinity to 0 of fx dx plus integral of 0 to x fx dx. Okay, the first part is 0, from case 1 only we can understand. Now we only need what? 0 to x of theta into e to the power minus theta x. Now here I have shown the derivation, but I will again write it in my journal and explain you better like what is happening in that derivation, or else you will feel scared, I know. Anyway, coming to this graph portion again. Let me replay it once more. And as you can see how the graph is drawn, I'm going to explain a little bit of CDF graph here. Now see, this graph, this CDF curve starts at x equals to, starts at 0, right? When x equals to 0. And it rises upward. This is to notice about, right? This rises upward, approaching 1 as x goes to infinity. But it never quite reaches 1, as you can see. It's a smooth S-like curve that flattens out at the top. Like this makes perfect sense. Why? Because the longer you wait, the more certain you are that the event has already happened. Okay? So you can relate that to real life too. But okay, let's not go into that clumsy real life. Let us stick to whatever we are studying. Okay, I will show you that. See, this is a CDF graph basically. Could you see the animation? Let me scroll up. Okay. Can you see the animation? This is basically the graph of CDF. Okay. Now, okay, coming to our next part. Now, this is the MGF portion. Now, here is where things get very powerful, because we are going to use the MGF to find the mean and variance, right? So, for our exponential distribution. So, now from here, I'm going to show my journal and calculate everything from here. And after that, we are going to find the mean and the variance, and then that will be all for today's class. Okay, just a moment that I change my slide. So, hi, now I will start with the writing parts. Like, how will we derive the CDF and the MGF? And from MGF, we are going to derive the mean and the variance, right? So, let me start with the PDF, okay? So, wait, how do we write the PDF? Let me write exponential distribution. Okay, so this is our today's topic, and now let us come to how do we write the PDF? It is like fx and theta is equals to theta e to the power minus theta x for x is greater than 0, and for x less than 0 it is just 0 only, 0 for otherwise. Okay, so that is why I was saying that for case 1, when x is less than 0, our fx will be 0 because the probability there will be 0 only because no events have even occurred. So let me write the basic things which you want to remember, which is theta is the rate parameter. And how do we denote exponential distribution? We denote by x follows exponential theta. Okay, so that is how we write for exponential distribution. Okay, now we are going to come to the CDF portion. Now for CDF portion, I always prefer that you draw a number line first so that you can understand how many cases will be there. Okay, so see, for the number line we have only two cases, right? Because let me draw and show you how do you basically write it. See, suppose this is the number line we are using for our CDF, okay? This is minus infinity and infinity. And here only one breakpoint is there, that is 0. So let us suppose that 0 is somewhere here, okay? Then case 1 will be what? See, case 1 will be what? From minus infinity to x, okay? Case 1 or 2, anything, it will always be minus infinity to x, okay? But the region for the first case will be what? Let me write it. Case 1 is x is less than 0, sorry, that will be case 2. X is less than 0. Now when x is less than 0, how do you write it? Since f of x is equals to 0 for x less than equals to 0, then integral, you can write it like this, or you can write directly that integral from minus infinity to x of fx dx will be equals to 0 only. Basically, f of x will be equals to 0 for x less than 0. Okay, so can you understand the logic behind why am I saying that x will be, the probability will be 0, right? So that is the first case, and now we are going to come to the second case, which is the important part, right? There we need to do the derivation. Okay, coming to the case number 2. Case number 2 is what? X is greater than 0. Now for that, how do you write it? It is minus infinity to x. That is for every cases, okay? Minus infinity to x fx dx will be equals to what? There will, we will here split the integral from minus infinity to 0 and then from 0 to x, and we have already known that for minus infinity to 0 it will be 0 only. So the first part will be cancelled, but you need to write it because you cannot miss any step in the exam, right? If you miss any step, then the teacher will think that you do not understand and you just have mugged up the answer. Okay, so minus infinity to 0 fx dot dx plus 0 to x fx dot dx. All right, so from here we can directly write that this portion will be 0 from the case 1, and now we need to compute only this part. So let us do it. It will be what? Integration of 0 to x, and what is our f of x? F of x is the PDF, right? So what is the PDF? That is theta into e to the power minus theta x. So let us write it. Theta into e to the power minus theta x dot dx. Now this theta can be taken outside because theta is a constant, right? So let us take theta outside, and then we are left with what? That is what is the integration of e to the power ax, that is e to the power ax by a. So that is a general formula for use for integration of this kind exponents, right? For e. Now then if we use that formula here, then what do we get? E to the power minus theta x by minus theta. and the limit is what, from 0 to x, right? And now you're just going to substitute the value of x with 0 and x, right? Upper limit minus lower limit. So let us do that. What do we get? Theta into e to the power minus theta x by minus theta minus, now if you put e to the power minus theta into 0, that is basically 0, right? So e to the power 0 is 1, anything to the power 0 is 1. So if we say e to the power 0 is 1, then it will be 1 by minus theta. So let me write it, 1 by minus theta. So we have substituted the values. Now we will just calculate it, okay? So it will be what? Theta into e to the power minus theta x minus 1 by minus theta. So now from here you can see that we can cancel out the thetas and you will be leaving out a negative sign. So what will be the answer? 1 minus e to the power minus theta x. Now let me highlight it. See, this is what we get from our case 2. Then how will you write the CDF? Now basically you will write the CDF like this. CDF, which is the capital Fx is equals to 0 for x less than 0 and 1 minus e to the power minus theta x for x greater than 0. So this is basically your CDF, right? Now here, after now we have studied what is the PDF, what is the CDF. Now we will come to MGF, right? Moment generating function. Now from MGF, we are going to find how do we are going to find the result of MGF. Then we are going to use that result in derivation of mean and variance. Okay. So let me first start with the MGF part. Okay. MGF. MGF will be what? That is expectation of e to the power tx, right? And how do we write it in integration form? We will write it like 0 to infinity. I'm sorry. 0 to infinity e to the power tx dot and fx. What is our fx? Fx is theta into e to the power minus theta x. That is our PDF, right? So it will be theta into e to the power minus theta x dot dx, right? So now what we are going to do, we can see that we can take out that theta again, that because that is a constant, right? So let us take out this theta outside. Now we are left with what? 0 to infinity e to the power tx minus e to the minus theta x, because the base is same here, the base is e. So we can directly compute these two values, right? So how will we do it? E to the power tx minus theta x dot dx. Now here also you can see that you can take the, in the power section you can take the x common, right? So if you take the x common, then what are you left with? Theta 0 to infinity e to the power x into t minus theta dot dx. Now here again we have got the form of e to the power ax of integral of it. Now if you take the integral of it, then you get what? E to the power ax by a, right? So what is our a here? That is t minus theta. So let me compute it. Theta e to the power x t minus theta by t minus theta, and here our limit is 0 to infinity. Now what is our upper limit? Upper limit is infinity and lower limit is 0. Now if we substitute the values of these in the x part, then what do we get here? Now here I'm trying to do something here. After before going to the next step, we can do a little bit of rewriting. Okay, yeah, as you can see, I can write it like this: theta into e to the power, if I take a minus sign outside, then what do we get? Minus theta into theta minus t x, right? We will just change the sign, and then we can say that theta is here, because theta is here because theta was in negative, right? So in divided by, if we take again a minus sign outside, then it will be theta minus t, and the limit is 0 to infinity only. Then how will we compute it? Now here we can see that we can take out a theta minus t from here outside, because that is again a constant. So if we do that, then what do we get? Theta by theta minus t, and what are we left with? E to the power this part, e to the power minus theta minus t x by minus 1. And the limit is same from 0 to infinity, right? So from here we can see that if I put now the limits in the upper limit minus lower limit, if we do that, then what do we get? See, if I put theta infinity here in place of x, then we can see it will be e to the power minus theta, right? So if I see that this will be e to the power minus theta, which is basically tending to be 0, right? So from here we can say, and if I put 0 here, then then what do we get? It will be e to the power 0, which is 1. So basically we will get here, okay, let me write with red pen only, theta by theta minus t, and it will be what? E to the power minus infinity will be tending to 0, so 0 plus 1, right? Because 1 by minus 1, it will be minus 1, and here we have a negative sign here, so we will be minus minus 1, it will be 1. So basically, this will be theta by theta minus t. All right. So here we can see that we have got our MGF, right? Now, once we get our MGF, it is very easy for us to find the mean and the variance, right? So let just a minute. Okay, so as I was saying that our MJF will be theta by theta minus t, right? So I hope that you have understood this part. Like 0, it was minus, right? Upper limit minus lower limit. So from here, negative sign, we have got minus 1. And so minus and minus 1 is plus 1, okay? So anyway, coming to the next part. Next is what we have to do, derivation. Derivative of m dash xt. For what we are trying to find the mean now. After we do the derivation, we will put that this t to be 0. Okay. So here we can see that if we do d by dt of theta by theta minus t, then we have to use the quotient rule, right? That is the division formula for the integration. So what is that formula? The formula is basically, I'm writing this in here, u by v derivative is v dot du by dt minus u dot dv by dt by v square. So this is the formula which we are going to use for using to get the mean of it. Okay. So now here we can see what is our u is our theta, and what is our v is our theta minus t, right? So let us see. Okay, let us take this red color only. Let us write it down, or else you will be it will be very confusing for you. It will be u is equals to theta we are taking. Now if I take du by dt here, okay, du by dt, it is what? 0 only. I'm sorry, 0 only, because it is a constant, right? Now we will come to theta minus t. Okay. Now that is v is equals to theta minus t, and therefore dv by dt is equals to minus 1, because here from here we are getting minus 1. Theta is a constant and t is also a constant. Theta is a constant, so it is 0, and from here we are getting minus 1. If you know the derivations, it will be very easier for you to understand what I'm saying. Okay. Okay, now coming to just replacing these values in the formula. Now see, I'm keeping the formula so that you can understand what am I writing. See, let me write u by v, the derivation is, that is v into du by dt. Now v is what? Theta minus t, theta minus t. And what is du by dt? Here we can see it is 0, so into 0 minus, here u is what? U is theta, so let us write theta, and theta dv by dt. What is dv by dt? It is minus 1, so just write minus 1, and divided by v square. What is our v here? Theta minus t, so it will be theta minus t whole square. Okay. Now it is computed. What do we get here? From what do we get from here? It is, this will be whole, everything will be 0, and this part is only theta, right? So it will be theta by theta minus t whole square. Now next you need to do what? Next you need to put t is equals to 0, right? If you put t is equals to 0, then you will get the mean. Now what is the mean? Let me write it. M dash x 0 will be theta by theta minus 0 whole square. So basically it is what? Theta by theta square, basically 1 by theta. That is how easily we have got our mean, right? So that is the power of MGF. That is why we learn how to use the MGF and the derivations. Now please do try these formulas in your home, so that it will be a very good practice for you. And even do a few more kinds of derivation so that it will be very easier for you when you write in the exam. Okay. Okay, now coming to the variance. Now for variance, what do we do? Now for variance, we will just again derive this portion, basically the double derivative. Okay. Now next, let us do m. Okay, this is highlighter. M double dash xt, basically theta by theta minus t whole square, d by dt, d by dt. Okay, so now how do we proceed from here? See, we can do what we can do, like, just see, d by dt, we can take 1 by theta as common here from these term. Okay, if we do that, then what are we left with? 1 by theta we are taking as common, then it will be 1 minus t by theta to the power minus 2. Why? Because this is in our denominator, right? So to the power minus 2. Now why am I taking this in power? Because that is way easier for us to calculate when we are dealing with derivations and integrations, right? Okay, so from here, this is basically what, after doing this, you need to do what? You need to put t is equals to 0. Okay, so now here we can see that 1 by theta is a constant, so we will take that outside. So if I take that outside, it will be 1 by theta dot d by dt of 1 minus t by theta to the power minus 2. And if I do it like in one step only, just let me write t is equals to 0. After that, we will substitute the value of t to be 0. Okay. Okay, so from the next step, we will write what? This minus 2 will come here if I do the derivation, and the power will be minus 2 minus 1, right? So it will be is equals to 1 by theta into minus 2, 1 by t minus theta, minus 2 minus 1 will be minus 3. And what is the derivation of this? We are applying chain rule, you can understand, right? Okay, so what is the derivation of this part? It is only 1 by minus 1 by theta, right? This part. So let me write minus 1 by theta, and everything where t will be equals to 0. Okay, so basically if t is equals to 0, so from here we can see this will be 0 by theta, this will be cancelling out, and from here we will be getting what? 2 by theta square. Okay, so from here we can understand that this is our expectation of x square. Now for the variance, what do we need? Expectation of x square minus expectation of x's whole square, right? And what was our expectation of x's expectation of x? That is our mean, right? And we got our mean to be 1 by theta. So let us do it. It will be 2, okay, not in the same step. Let me write variance of x is equals to expectation of x square minus expectation of x's whole square. So here it will be what? 2 by theta square minus 1 by theta whole square. Now what is basically 1 by theta whole square? It is 1 by theta square. So 2 by theta square minus 1 by theta square is equals to 1 by theta square. So here, from here we have got our variance, right? Now, as you can see, like, this is a small observation which I want you to see, is that from the variance we can get our standard deviation, right? Now, what is standard deviation? It is basically root over of variance. Now if you see, like, root over a variance is what? This variance is root is 1 by theta again. Now here, from here we can understand what was again the result of 1 by theta. That was the mean, right? So from this from these observation, you can understand that the standard deviation is 1 by theta, which is the same as the mean, right? Now this is actually a very famous and special property of the exponential distribution, which is that the mean equals the standard deviation, right? And that is basically, you can say, that a hallmark of the exponential family, because this is very important and a very nice observation which you can do. And just a moment. So basically that is it for our today's class. And now if I go through everything what we have okay, from here in this step I have missed, like, I have directly written 2 by theta square. Now if somebody has not understood, then I am explaining it, like, why I have written it, because this t was we were taking to be 0, so this portion will be 0, so we will be left we will be left with minus 2 and here minus 1, so we are getting 2 here, and theta we are getting theta square. Okay, so just a clarification which I wanted to make because I have not explained this part. Okay, so basically that is all for today's class, and this is what exponential distribution is about. That is its memoryless property, which means that the past doesn't affect the future. Okay, now if you have already understood, even if you have not understood, I will explain you with an example. See, if you have waited already 5 minutes for a bus. Okay, you are waiting for a bus for 5 minutes. The probability of waiting another 5 minutes is exactly the same as if you just arrived. That is what I mean. The past doesn't matter for the future. That is wild, and it is a topic for another video. Okay, so I'm not running it here again. Now I'm just changing the slide to my html file which I made. Okay, so we will get a quick summary of what we did today in class. Okay, just a moment. Okay, we have studied the mean, the variation, variance, and the standard deviation, everything. This is the special property which I was discussing about, and now we will come to the summary at glance. Okay. Okay, so basically that is it for today, and we have covered the full theory of the exponential distribution from the definition to the CDF and the PDF, the MGF, and we derived the mean and the variance from scratch, just like you would do in your exam. Okay, every step which I showed will you have to follow that, and okay, that is basically everything put together. And here you can see everything, every formulas which I was mentioning. Okay, that is a pdf, cdf, mgf, mean, variance, standard deviation. Okay, and here you can see what is the notes, and this is like something, just a quick glance, like you got to understand. You just want to revise what is exponential distribution, just look at this summary and you can understand. Okay, because I have written the side by side notes here also. Now if this video helped you, please give it a thumbs up, and it really helps the channel grow. And subscribe if you haven't already, and drop a comment in the comment section if you have any doubt and any question. I will reply to it, and see you in the next class. Until then, keep learning, keep going, and take care of yourself. From here you can subscribe to the channel, and definitely I will upload these notes and my handwritten notes also in my blog account, and this slide I will upload it directly as a link. Okay, so yes, thank you for watching, and see you in the next class. Bye bye.